Okay, so it seems like we all agree that this comparison statement isn't true. It's not true that for every $3 that 8th grade plans to raise, the 7th grade plans to raise $1. So it sounds like someone made a mistake when they wrote this comparison statement. But that is okay. Making mistakes is just a normal part of being a problem solver. And it doesn't have to mean you just throw out all your work and start all over. One of our CT practices is called debugging, and it's about finding and fixing mistakes to improve our work. So when we're debugging, we're not just going to throw out something because it has a mistake. We're going to think about what specific things we could think to make our work better and build on all of the great thinking we've already done. So let's think about how we could debug that statement we were just looking at. So when I'm debugging, one of the things I like to do is just kind of go over the thinking I put into my solution. Just kind of go over it again and think about it again. So what do we think this person was thinking about when they wrote this comparison statement? We know that they were making a comparison between the 8th grade and the 7th grade fundraising goals. So let's just write those down so we can see them and remember them. So the 7th grade goal was $450. And the 8th grade goal was $150. What else do we think this person was thinking about? They used the number 3 and 1 in the statement. Why do we think they were doing that? Why did they choose 3 and 1? Maybe they're thinking of something like 3 times? Something else? Maybe they noticed that 150 times 3 is 450. So 3 times the 8th grade goal is the same as the 7th grade goal. Let's write that down. So that makes sense. I think it makes sense to keep that idea of this comparison having something to do with 3 times. Let's not throw that part out. Keep that. But why did we decide this statement wasn't true? We were looking at some examples and writing them down in a table, right? So we said, if this statement were true, when the 7th grade had $1, the 8th grade would have $3. When the 7th grade had 2, the 8th grade would have 6. And no matter how many times we added $1 more to 7th grade and $3 more to 8th grade, the 8th grade was always going to have more. And why did we decide that didn't make sense? Why didn't that work? Yeah, it doesn't make sense that 8th grade is always going to have more when their goal is actually lower than the 7th grade. It should be the 7th grade that has more. So that's why we decided this statement wasn't true. Let's take that out of our table, that thinking out. So we want to keep that 3 and 1, that 3 times kind of thinking, but we want the 7th grade to have more. What change could we make to our comparison statement? So instead of just throwing it out, what change could we make to make the comparison statement better, do you think? Yeah, why does it make sense to do that? I think that's a good idea. I want to hear more. Yeah, I think that makes sense. So she said we could just switch the 3 and the 1 in this statement, because then the 3, which is the bigger number, would go with the 7th grade, and the 7th grade has the higher goal. I think that makes sense. Let's try it out. So now it says for every $1 the 8th grade plans to raise, the 7th grade plans to raise $3. So does that make sense? Let's try it out with our examples again. If this were true, then when the 7th grade had 3, the 8th grade would have 1. When the 7th grade had $6, the 8th grade would have $2. And the 7th grade is always going to have more now. Not only that, but they're always going to have 3 times what the 8th grade has, which is the same as we noticed was true for their goals. So that's it. We debugged that statement. All it took was one small change, and then we had fixed it. We didn't have to throw it all out. So this is something we're going to do a lot this year. We're going to tackle a lot of hard math problems, and we're going to make mistakes, and that's just part of being a problem solver. But we're also going to practice debugging, because that's just part of being a mathematician and a computational thinker. And we're also going to help each other debug, because that is an important part of being a mathematician too.